Alright, we're going to do part 3, calculus 105, sin 3 to 105, 070, 620. So now let's start. 73 part 1. It says, find the value of c that satisfies the equation f of b minus f of a over b minus a, f prime of c equals b. In the conclusion of the mean value theorem for the function in an interval. So now we have f of x equals x squared plus 2x plus 4 on this interval. Derivative is this, and that's 2x, 0, you don't need it. F of b minus f of a, b minus a, so f of 3 minus f of negative 3, negative 2. 3 minus 2 equals this. That's going to be 3 squared, 2 times 3, negative 2 squared, 2 times negative 2. That's going to be 9 plus 6 plus 4, 4 minus 4 plus 4. All this together and all this together is going to give you, next page, 19 and 4. So now we have 19 minus 4 is 15. 15 divided by 5 is 3. So 3 equals 2x plus 2. So now we have to solve. So 3 minus 2, these are gone. So we have 1 equals 2x. And now we have divide by 2, so x must be 1/2 for it to work. Alright, next one. Use the graph of the function f of x to locate the local max extrema and identify the intervals where the function is concave up and concave down. Alright, so up here there is a max right there at negative 1,5. And down here there's a min right there at 1, 1. So local min at 1. Local max at negative 1. Now, concave up and down. Right here is going concave down. Right there, concave up. So concave up right here, 0 to infinity. And concave down from negative infinity to 0. From a piece of cardboard, 30 inches by 30 inches square, square corners are cut, the other corners are cut out, so that the sides can be folded out to make a box. What dimensions will yield a box of maximum volume? What is the maximum volume? Alright, so volume equals length times width times height. All the sides are 30 minus 2x, 30 minus 2x, all the way around. So length times width times height, 30 minus 2x, 30 minus 2x times x. Fold this out. 900 minus 60 plus that. That's 900 minus 120x plus 4x squared. We multiply this by x. 900x minus 120x squared plus 4x cubed. Rewrite it this way. So now, derivative is going to be 12x squared minus 240x plus 900. Second derivative is going to be 24x minus 240 plus 0. You don't need the 0. Just right here. So we have the v double prime is this. Now, let's set the first derivative equal to 0. There it is, equal to 0. Divide by 12, divide by 12, divide by 12 by 12. X squared minus 20x plus 75 equals this. So now, for this one, the possible numbers are 75 and 1, 25 and 3, 15 and 5. 5 and 15, negative and negative. Is that going to give you 75? Yes. Add them together, 20, yes. X minus 5 equals 0. Add 5 by 5, x equals 5. X minus 15 equals 0. Add 15 by 15, x equals 15. So, 5, 15 critical points. Let's try them in the second derivative, see what happens. Okay, so we have v double prime is this, v double prime of 5, 24 minus that, 120 minus that, so it's a negative, which is less than concave down, means it's a max right there, this number. The other one, v double prime of 15, 24 times 15 is 360 minus that, is positive 120, so it's concave up, that's a min, but we want this one, the max, the 5. So now, put it back in the original problem, 5. V of 5 is 30 minus 2 times that, 30 minus 2 times that, that's 30 minus 10, 30 minus 10, 20 times 20 is 400. 5 down here, 5 times that is 2,000. So 2,000 inches cubed is the maximum volume. Solve the initial value problem. ds dt equals this. So now, multiply by dt, these are gone. So we have ds equals this. So now, integral of 1 ds, integral of this. So This is going to use S. So this is the integral of cosine t is sine t. The integral of negative sine t is cosine t plus c. So S of t is this. So now, initial condition says if you put pi over 2, pi over 2, pi over 2 plus c, you're going to get 10. So let's go sine of power 2 plus cosine of power 2 plus c equals 10. So now this is going to give us 1 plus 0 plus c equals that. So 1 plus c equals that. Minus 1, c equals 9. So now that means that this problem right here, s of t equals sine of that, cosine of that, is now going to be sine of, s of t is going to be sine of t, cosine of t plus 9. And we use these two formulas, the integral of cosine, the integral of negative sine. The sum, you can do this in a calculator. In fact, let me just do the first one so you can see how it's done. Okay? So let's do this. Just the first one. So that one, so you're going to go math, move it down till you get to summation. There it is. So now in the little blocks right there, you're going to put in the numbers that'll help us. So you can see this machine. I'm going to put X, I'm going to put a 1 up here, I'm going to put an 18, and right there I'm going to put the X. X, K, doesn't matter, you can just do either way you want. Hit sum, 171. So you can use this to get the answers for all these problems here. Alright. So now, you can work this out yourself. Use a graphing calculator. Alright, next problem. Function f and g are integrable, and the integral from 3 to 7 as this one is 9. The integral from 3 to 7 of g of x is this. And then from 6 to 7 is that. Evaluate the integral below. This one right here. First of all, I'm going to take this minus away and flip these numbers. You can do that. 3, 7. Now, we know that 3 and 7, and you have 3 there, but 3, factor it out. So now we have integral of this right here. Do we have something for that? Yes, it's up there. And actually it's a 9. So 3 times this is a 9. 3 times 9 is 27. Evaluate the final integral using the fundamental theorem of calculus. We're going to find the area here, this yellow spot right there. So how are we going to do that? So the integral from 0 to 1 of this, and use this formula. And that's going to be 2 plus 1, 2 plus 1, 1 plus 1 plus 1, 3 power, 2 power. And put these, now we're going to put the numbers in. Put the 1s, put the 0s, 1, 1, 1, and then these 2's cancel and it's still 1, plus 3, 0, 0, 0, these are all zeros. 1/3 of that is going to be 1/3 plus 2, 2 is 3 times that, 3 times that, now we have 1/3, 6/3, can you add those together? Yes, 1 plus 6, 7/3, 7/3 minus 0 is still going to be 7/3. Alright, next one. We have evaluate the following integral using the fundamental theorem of calculus. There's the area we're looking for. The top is this one, the bottom is the graph. So now, integral from there to there of this function. There, use this formula again. 2 plus 1, 2 plus 1, 1 plus 1 plus 1. So we have 3, we have 2. This reduces to square. So now put the one numbers in there. 5, 5, 5, and negative 1, negative 1, negative 1. So that's going to be 125 minus 50 minus 25. Negative 1/3 plus 2 plus 5. So now these numbers right here, let's go ahead and take off all the parentheses off. So we have this number, so we have 125/3, 1/3, 126, and all these numbers right here is 78, it's negative 78. Divide these numbers, is 42. 42 minus that is negative 36. The area under there is negative 36. Use the fundamental theorem of calculus to evaluate the following definite integral. Integral over there, you're going to use these two formulas. 4x, 1, 2 plus 1, 2 plus 1, 6x, from 1 to 4, and leave it like this. Now put the number in there. 4, 4, 1, 1. That's going to give you 64 times that, 256 over 3, 24, minus this one, minus that one. So now, we're going to put this one and this one together, and 4/3, and that one is there. And this divides this 84 times, so we have 84 plus 18 is a 102. Evaluate the following integral using the fundamental theorem of calculus. we have the integral of this product. Let's just multiply out the FOIL. 3 times that is 3x, 3 times that is 28, 21, that times that is negative x squared, and that times that is negative plus 7x. Put them together, you have negative x squared, x and x is 10x, and the 21 there. Now we're going to go ahead and use this formula. Add 1, add 1, add 1, add 1, so we have to the 3, to the 3, to second, cube it, 3, 5 squared, divide this a little bit. Now I'll put these numbers in there. So now we're going to have 7's in there, 3's in there. So 7, 7, 7, 343, 7 times 7, 48 times that, this number, 7 times that number. 3, 3, negative 27, 3, this is going to be 9 times 5, 45, minus 63. So now we're going to take up all the parentheses off. This one's copy it, change the sign, change the sign, change the sign. So this number and this number, it's going to be 316 over 3. This, and this is that one. Now, multiply by 3, multiply by 3, we're going to have 316 plus 3 over 348 plus 3, and put this together as one big fraction. 348 minus that is 32 over 3. That's it, leave it alone. We're done. Alright, next one. Find the area of the region bounded by the graph of f and the x-axis in given interval. So x-axis is 0 minus the bottom part of the graph. So we have this. Subtract those. You have this minus, minus, plus, minus and a plus. Now this is going to be negative x squared plus 40. Now this is what we're going to use using this formula. 2 plus 1, 2 plus 1, 40x from 4 to 2 to 4. So now put the numbers in. So we put 4's in there, 2's in there. That's going to be 64 over 3 negative plus 60, 160 minus negative 8/3 plus 180. So it's going to be this number plus this, plus and minus. Put this together, 56 over 3, that one together. Now multiply by 3, multiply by 3, you have 243, and this one together. This right here is going to give you 184 over 3. That's it, leave it alone. Simplify the following expression, the derivative of this integral. Alright, let's flip this around. Put a negative sign here, put the x up there, the 5 there. So now we can say this is going to become negative square root of x to the 4th plus 1. Simplify the following expression, d dx of this. So what we're going to do is this, just put the x cubed in there, squared, and the derivative of this. So now, 1 over x to the 6, 3 times 2 is 6, derivative of this is 3x squared, 3x squared on top, and then we can reduce this, have a 2 and you have a 6, take the 2 from the 6 in the bottom, 3 over x to the 4. Evaluate the following integral. So, this number to the power times the derivative. The derivative of this is 1, so it's ready. So, x minus 3 to 3 plus 1, 3 plus 1, x minus 3 to 4, or 4 from 0 to 3. Put the 3 in there, put the 0 in there. 0, 0, 0, 0, minus 3, minus 3, minus 3, minus 3, 81 over 4, negative 81 over 4. Also notice, remember I said that this is a 1 right next to it, like that. So that's when we can use that. Alright, number 87. Find the average value of the following function over the given interval. There's a function, interval. So 1 over 9 minus 1, the numbers right here. Integral of 1 to 9 of that function. Finding the average of this guy right here. So 1 over 8 from this, integral of this. Now we integrate this. X2 plus 1, 2 plus 1, 1 plus 1 plus 1, from 9 to 1. So now we have this right here. Now we're going to put the 9 there, 1/8 of this, and negative 1/8 of this one. So we have 729, 81, 111, 111. So now this is going to become that one right there. We're going to factor out the 1/8. 1/8 comes outside. This is still left inside. Take up all the parentheses. Negative, negative, positive. Put together this one and this one. 728. This one and this one is that. So now to have the same denominator, multiply by 2, 2, 3, 3. 1456 over 6, 240 over 6, same numbers, put them together. 1456 minus 240 over 6. That's going to be 216 over 6. 8 divides this number, 152, 6. And 2 times 3, and we know that the 2 divides this one, 76. So we have 76 over 3. That's it. Find the points at which the function f of x equals this equals the average value. So let's first find the average value. So it's be 1 over 2 minus 0, integral of this, at half, so integral of this one here. So this is going to be 5x, 1 plus 1, 1 plus 1, 5x minus 4x squared over that, divide this out. 5x minus 2x squared from 0 to 2. Put the 2 in there, put the 0 in there, and the half still up there. So now we have 10 minus 8 is 2, 1 half of 2 is 2 over 2 is 1, and 0, 0, 0, half of 0, 0, 0, so 1 minus 0 is 1. So now set the function equal to the average, this one right here, equals the average value. So solve this one. So it's minus 5 minus 5, these are gone, minus 4x equals negative 4. Divide by negative 4, divide by negative 4, so x equals 1. That's the answer we're looking for. Use the substitution, u equals x squared, to find the following indefinite integral. Alright, so let's rewrite this way. So the derivative of this, if this is u, then u prime is 2x. Is that what we have right there? Yep. The derivative of this is right there. We can use this formula right here. So 5 plus 1, 5 plus 1, that's going to be a 6 over 6, or you can take that 6 out. 1/6 of x squared plus 6 to the 6 plus c. Use the substitution. U equals 6x squared minus 5. So the derivative of that is 12x. So let's rewrite this. Negative 12 times that, let's put it over here. The sine of 6x squared minus 5 times negative 12x. Now, derivative of this is going to be just 12x. That's not it. So there's a negative there. So we're going to factor the negative out. Now we have sine of 6x squared minus 5, 12x. Is that the derivative of this? Yes. So now we can use this formula. So that means that this right here will become negative cosine of 6x squared minus 5. And negative is a positive, so cosine 6x squared minus 5 plus c. There's our answer. Use the substitution, u equals 5x squared plus 2x. And if you take the derivative of that, that's going to give you 10x plus 2. Rewrite it, square root first, then this. The derivative of this is 10x plus 2, exactly right there. Use this formula. So this is correct to the half power, rewrite it. So 1 half plus 1, 1 half plus 1, that's 1 half, 2 halves, 1 half, 2 halves. That's going to be 3 halves, 3 halves, and we can get the reciprocal of this, means flip it upside down, right there. 2 over 3 times 5x squared plus 2x to 3 halves plus c. Use a change of variables. Okay. Well, if y equals e to the mx and y prime equals e to the mx times mx prime, and y prime equals e to the mx times m, so the derivative of this is right there. And if the integral is f prime over f, we can become ln of f of x plus c. So we have f of x and f of x prime almost. Let's put a 1 here. 1 times that, same thing. 2 over 2, same thing. 1 over 2 times that, same thing. So now let's bring this 2 right here. And now e to the 2x and derivative of this is 2, just like this one. So now we have the original function, the derivative on top. So this is going to become what? The 1 half ln of the bottom part, e to 2x plus 7 plus c. Use change of variables. Okay. So we have cosine of 7x. If you have cosine of f of x times f prime of x, you can become sine of f of x plus c. Well, we have cosine of 7x. The derivative of that is 7. It's not there. So let's put a 1 here. 7 over 7, same thing. 7 times 1 over 7, same thing. So now bring the 7 in. So 1 over 7 times this. So now cosine of 7x and the derivative of that is 7. Yes. So now we can use the formula. So it becomes sine of 7x from 0 to 40 power 42. Put the numbers in here. Power 42 and 0 right here. So we have 1/7 of this, 1/7 of this. So now, part 1. Let's go to part 2. So 7 times 6 is 42. Divide the 7's out, so power 6. This one's 0, 0. So the sine of power 6 is 1 half, and the sine of 0 is 0. So 0 times that is 0. 1 times 1, and 7 times 2 is 14. 1 over 14 minus 0 is still 1 over 14. Use a change of variables. So we have this, but the derivative of e to 3x, derivative of 3x is 3. So let's do this. Let's break this out. Take a 5 out. Leave the 3 in there. 5 times 3 is 15. So now we have this. Put the 3 there. E to 3x times 3. Is that the derivative right there? Yes. Looks just like that. E to the x. So now we have 5e to 3x from 0 to 1. Put the 1 in there. Put the 0 there. that's going to be 5 e to 3. E to 0 is 1. 1 times 5 is 5. So e to 5 e to 3 minus 1. And we're done. Alright, this one. One way to do it, let's just do it this way. We say this number times the derivative inside. The derivative of the inside part is it's a negative 5x4. So it's not ready yet. Fix it. So we put a negative, negative 5x to the 4, negative right here. So negative times the integral of this to 1 plus 1 from 0 to 1. So now there again, u equals 3x plus that, u prime is negative 5x to the 4, which is what we did right there. So now this is a 2, this is a 2. Can we put the 1 in there? Yes. Can we put the 0 in there? Yes. So we have 1 to the 5th, 0 to the 5th, 1, 1, 1, 1 is there, 0, 0, 0, 0 is 0, and we need to subtract these numbers, So we have this number squared on top, over that. So now we have 4 over 2, and we have 9 over 2. So this is going to be negative 4 over 2, which is, and we have positive 9 over 2. So add these numbers together, 9 minus 5, 9 minus 4 is a 5 over 2. Use a finite approximation to estimate the area under the graph of a given function on the stated interval as described. F of x equals x squared between 0 and 3. So between 0 and 3, we go 0 to 1.5 to 3. We got little rectangles there. Using a right sum with two rectangles of equal width. So there's the equal width right there. So if you put 1.5 in there, you get this number. And if you put 3 in there, you'll get this number for that. Now, so the area of this must be 1.5 times this number. So 1.5 times 2.25 is 3.375. And the area of this one must be 1.5 again times 9. That's going to give you a 13.5. If you add these two areas right here, 3.375, 13.5000, you're going to get 16.875. Is for the area right there in the yellow. Suppose the integral of this is negative 2. Find this one and find this one. Let's do this one first. So then you go from 7 to 8 of 9 f of u du. Take the 9 out. Now, what is this right here? We know it's going to be a negative 2. 9 times negative 2 is a negative 18. Got it. The other one. From 7 to u, I minus this. Put the minus over here. We're left with 7 to 8 f u. Negative of, what is this? Negative 2. So negative of a negative is a positive. Find the derivative of this. The derivative of this is just going to give you that answer right there. Evaluate the integral by using the given substitution. So x is this, rewrite it. It's cosine of 6x squared plus x. U equals 6x squared, and the derivative of that would be 12x. Is it? U equals x 6. Oh, okay. That's gonna be 12x, but we don't have that in there, do we? Nope. So let's fix it. Let me write this right here too. We know that u prime is 12x squared. So now, that's what we gotta have in there somehow. So let's go from there. So this is x only. You know what? That's not enough. X is not enough. 1x is still not enough. So let's put 12 over 12. It's 12 times 1 over 12. And then bring the 12 in. So now the derivative of this is 12x right there. 1 to 12 of this. So now does this fit the formula? F of x, cosine f of x times f prime of x? Yes. Now we can integrate this as sine of 6x squared plus c. 1/12 of this right here. The integral dx over this is complete the square. Complete the square means take half of this number, square it, and subtract it, half of this number. So this plus this minus this is gone. It's not. So now half of this is negative 1, negative 1. Negative 1 to negative 1 is plus 1. Negative 1 to negative 1 is plus 1. So you have 1 minus 1, which is the same thing as the original problem. Now rewrite this. This factors into x minus 1, x minus 1, x minus 1 squared, plus 36, and that's 6 squared. So this is going to be 1/6 tangent inverse of x minus 1 over 6 plus c. From this one, the integral dx over x squared plus a squared equals 1 over a times tangent inverse of x over a plus c. This formula, we use it for that right there. If the general solution of the differential equation is y of t equals c e to the negative 4t plus 8, what is the solution that satisfies the initial condition y of 0 equals 3? So now, y of t equals c e to the negative 4t plus 8. So put the 0 in there. Y of 0 equals c e to the negative 4 times 0 plus 8 equals 3. That's going to be e to the 0, and e to 0 is a 1. C times 1 is c. 8, 8, 8, bring it down. 3, 3, 3, bring it down. So now we have c plus 8 equals 3. Minus 8, minus 8. So c is negative 5. So that means the original problem right here now becomes y of t equals negative 5 e to the negative 4t plus 8. Find the general solution of the following equation. So what we're going to do is going to rewrite this first. Y prime of t over xt to the 8, multiplied by t to the 8, multiplied by t to the 8. Y prime of t equals t to the 8. Integrate both sides. Y of t equals t to the 8 plus 1 over 8 plus 1 plus c. So that's going to give you t to the 9 over 9 plus c. So this is the final answer using this formula right there. Find the general solution of the differential equation, and we need this formula. X to the n is x to the n plus 1 plus c. So dy dt is this. Let's cross multiply this. That times that. That times that. 8y dy equals 9t squared dt separated. So now we have integral left side, integral right side. This is going to be a to the y plus 1 plus 1, 1 plus 1. T 1, 2 plus 1, 2 plus 1. So 8y squared over 2, 9y t cubed over 3 plus c. Now divide by 4, divide by 4, divide by 4. This is y squared, 3t cubed over 4, and c1 over 4, whatever that is. Just a constant. Part 1. Part 2, we have y squared equals this. So now, square root of this side, square root of this side, plus or minus. And then this is going to be y equals plus or minus square root of 3t cubed over 4 plus c1 over 4. This one is converted. Let's say big C equals c1 over 4. If I substitute that in there, we're going to have y equals plus or minus square root of 3t cubed over 4 plus big C right there. Find the general solution of the first order linear differential equation is this. What solution satisfies the initial condition y of 0 equals 5? So here's the problem. Put y is 0. C equals e to the 0 right there. 0 times 9. 16 is 5. So that's 0. E to 0 is 1. 1 times c is c. 16, bring it down. 5, 5, 5, bring it down. So add 16, so c must be what? 21. So for this problem here, this letter c is now going to be what? 21. So y of t equals 21 e to the negative 9t minus 16. Find the general solution of the following equation. Formula. First order linear differential equation, y prime of t equals k y e times plus b. Then y of t has to be c e to the kt minus b over k. So y prime of t is this. This is a first order linear differential equation. So this is 5 and this is negative 4. So y of t equals, that solution is going to be c e to the 5t, and it's going to be the number b over 5. So negative negative is a positive. So the solution of the first order linear differential equation is going to be y of t equals c e to the negative 5t plus 4 fifths. That's the solution right there.